Hello, and welcome to Bedtime Universe. Find a comfortable position. Let your shoulders fall. Let the muscles in your face soften, and allow your breathing to find its own slow, peaceful rhythm. Tonight, we are leaving the busy world behind. We are closing the door on our worries and our lists of things to do, and we are opening a window to the cosmos. There is no need to understand everything. There is no need to remember the details. All you need to do is listen and allow your mind to drift. We are about to embark on a quiet journey, a gentle float through the grand, silent theater of space. Let the story of the universe be your lullaby. Let us begin. Our journey starts here, on our small, precious world. Feel the gentle pull of its gravity, a constant, reassuring embrace. From our vantage point, the universe appears as a tapestry of distant, twinkling lights against a canvas of deep, velvety black. But this stillness is an illusion. Everything we see, and everything we are, is part of a grand cosmic dance, moving through space at unimaginable speeds. Our Earth spins, it orbits the Sun, and our entire solar system glides through the spiral arm of our home galaxy. We are travelers, all of us, on this pale blue dot. It is our ship, our sanctuary, a tiny, fragile island of life in the vast cosmic ocean. For a moment, let us appreciate this home, the feel of the air, the sound of the wind, the warmth of this living world, before we venture out into the quiet cold. Our first step takes us to our closest companion, the moon. It hangs in the darkness like a pearl of ancient wisdom. For all of human history, it has been our constant neighbor, its phases marking the passage of time. As we draw closer, we see its surface is not smooth, but a landscape of profound silence. Craters, large and small, tell the story of a violent past, a loyal guardian that has shielded the Earth from countless impacts for billions of years. There are vast, dark plains of cooled lava, the seas of tranquility and serenity. And because it is tidally locked to us, it always shows us the same familiar face, while keeping its far side a mystery for so long. The moon's gravity pulls on our oceans, a silent, powerful hand that stirs the waters of our world. It is more than just a rock in the sky. It is part of Earth's own story, a silent, glowing reminder of our place in the cosmos. We drift onward now, toward the heart of our system, toward the star that gives us everything, the Sunday, from a safe distance. We watch it not as the familiar disk in our sky, but as the colossal, fiery sphere it truly is. It is a furnace of nuclear fusion, a churning, boiling ball of plasma so large that over 1 million Earths could fit inside it. Great arcs of energy, taller than dozens of worlds, leap from its surface. Dark sunspots, cooler regions on its face, are themselves larger than our planet. And yet, for all its power, its light is the gentlest touch, the source of all warmth, all energy, all life. The light that touches your face during the day has traveled for 8 minutes across 150 million kilometers of empty space just to reach you. The sun breathes a constant wind of particles, the solar wind, which flows out past all the planets, creating a protective bubble around our solar system called the heliosphere. It is our protector, our engine, our anchor in space. Leaving the sun's immediate warmth, we glide out into the wider solar system. We pass Mercury, a world of extreme temperatures, scorched by the sun during its long day and frozen in its deep, dark night. Then Venus, shrouded in thick, toxic clouds of sulfuric acid, a world with a runaway greenhouse effect, a beautiful but haunting reminder of how fragile a planetary balance can be. We continue outward, into the realm of the giants. Here is Jupiter, the king. It is a world made not of rock, but of gas, a colossal sphere of hydrogen and helium. Its sheer size is difficult to comprehend. Its stripes and swirls are massive weather systems, storms that dwarf our own planet. And there, the Great Red Spot. A hurricane that has been raging for centuries, a swirling vortex so vast, our entire Earth could be lost within it. Jupiter has a family of its own, with dozens of moons. One of them, Europa, is covered in a shell of cracked ice. And beneath that ice, scientists believe there lies a vast, dark ocean of liquid water warmed by the pull of Jupiter's gravity. A hidden ocean, perhaps holding secrets we can only dream of. Further on, we see the jewel of the solar system, Saturn. Its rings are one of the most beautiful sights in the universe. They are not solid, but are made of countless billions of pieces of ice and rock, from tiny dust grains to chunks the size of mountains. Each piece orbits Saturn in a silent, graceful dance, forming a disk so wide yet so incredibly thin. Saturn, too, has fascinating moons. Like Titan, a world with a thick atmosphere and lakes and rivers not of water, but of liquid methane under a hazy orange sky. We drift to the cold, distant frontiers. Uranus and Neptune, the ice giants, they glow with serene shades of blue and aquamarine, their atmospheres filled with methane ice. These are worlds of extreme cold and fantastically fast winds, silent, lonely sentinels in the deep dark. And beyond them lies the Kuiper Belt, a vast ring of icy bodies, the remnants from the formation of our solar system. Here, Pluto resides, no longer a planet, but the king of this distant realm. And even further out, in the blackest depths of space, lies the theoretical Oort cloud, a vast spherical shell of trillions of comets, loosely bound to our sun, marking the very edge of its gravitational influence. This is our home. This vast, complex, and beautiful system, and yet it is only one star system among billions. Our perspective shifts. We pull back, further and further. Our solar system becomes a tiny point of light, lost in the crowd. We are now in the interstellar space of our galaxy, the Milky Way. It is a colossal, spinning city of stars, a spiral galaxy containing over 200 billion suns. We are located in one of its quieter suburban spiral arms, the Orion Arm. From here, we can see the breathtaking structure of our galactic home. Look around. We are floating through regions of incredible beauty. These are the nebulae, the stellar nurseries, great clouds of gas and dust, so vast they stretch for light years. They are not grey and dark. They are illuminated from within by the light of newborn stars, glowing with vibrant colors. The deep red comes from energized hydrogen, the blues and greens from oxygen. Within these soft cosmic clouds, gravity is at work. Slowly, patiently, over millions of years, it gathers clumps of gas and dust, pulling them inward. As they collapse, they heat up, forming protostars. And when the core becomes hot and dense enough, nuclear fusion ignites, and a new star is born, its light pushing away the remaining gas, revealing itself to the universe for the first time. The universe is not a static place, it is constantly creating. Even now, as you rest, new stars are being born, and what a variety of stars there are. We see the brilliant blue giants, massive and intensely hot. They live fast, burning through their fuel in only a few million years, and end their lives in the most spectacular explosions the universe has to offer. A supernova. For a few weeks, a single supernova can outshine its entire galaxy. That explosion seeds the cosmos with heavy elements: carbon, oxygen, iron, the very building blocks of planets and of life. Every atom in your body, except for the most ancient hydrogen, was forged in the heart of a star that lived and died long before the Earth was formed. You are, quite literally, made of stardust. Then there are the long-lived, stable stars like our Sun, gently burning for billions of years, providing the steady energy needed for life to evolve. And most common of all are the red dwarfs. Small, cool, and dim, they sip their fuel so slowly they can live for trillions of years, far longer than the current age of the universe. In the far distant future, they will be the last lights to go out in the cosmos. We see the end of stellar lives too. Stars like our Sun will eventually shed their outer layers, creating a beautiful, glowing planetary nebula, and leave behind their core a white dwarf. A sphere about the size of Earth but incredibly dense, glowing with leftover heat. Over eons, some of these white dwarfs will cool and crystallize, turning into cosmic diamonds the size of a planet. But when the most massive stars die, their cores collapse under their own gravity with such force that they crush matter out of existence, forming either a neutron star or a black hole. A neutron star is a city-sized object with the mass of a sun, so dense that a single teaspoon of its material would weigh billions of tons. Some spin rapidly, beaming out radiation like a lighthouse. We call these pulsars, the most precise clocks in the universe. And then there are the black holes. Regions of space-time where gravity is so strong, nothing, not even light, can escape. They are the true ghosts of the cosmos. Invisible, silent. Their presence only known by the way they bend the light of stars behind them, or by the glowing disk of matter that spirals into them. At the very center of our Milky Way lies a supermassive black hole, Sagittarius A star. It has the mass of 4 million suns. It is not a cosmic vacuum cleaner. It is the gravitational anchor of our galaxy. Its immense gravity is the calm, steady hand that orchestrates the orbits of billions of stars, including our own Sun, keeping our cosmic city together. Now, let us pull back even further. Our beautiful Milky Way becomes just one island of light in an archipelago of galaxies. The closest large galaxy to us is Andromeda, another majestic spiral, even larger than our own. It is currently 2.5 million light-years away, which means the light we see from it tonight began its journey when our earliest human ancestors were first walking the Earth. It is moving toward us, and in about 4 billion years, our two galaxies will begin a slow, graceful merger, a cosmic dance that will create a single, new, giant galaxy. As we look deeper into space, we see galaxies of all shapes and sizes. Spirals, ellipticals, and irregular clouds of stars, trillions of them stretching out in every direction. And they are not scattered randomly. They are organized. They are gathered together by gravity into groups, clusters, and superclusters. These clusters are all connected, forming long, intricate filaments of light that stretch across the universe, separated by vast, dark voids of near-complete emptiness. This is the cosmic web, the largest known structure in the universe. It is a luminous, living tapestry that gives the cosmos its shape. Our galaxy is but one small thread in this immense design. And what fills the space between these structures? What holds them together? Mystery. We can only see about 5% of the universe. The rest is invisible to us. About 27% is thought to be dark matter. We cannot see it, we cannot touch it, but we can detect its gravitational pull. It is the invisible scaffolding upon which the cosmic web is built. It is the unseen mass that keeps our galaxies from flying apart. It is a silent, invisible presence, shaping the universe in ways we are only just beginning to understand. And the remaining 68% of the universe is even more mysterious. It is called dark energy. It is a form of energy woven into the fabric of space-time itself, and it has a strange anti-gravitational effect. It is not pulling things together. It is gently pushing everything apart. Because of dark energy, The expansion of the universe is not slowing down, it is accelerating. The vast voids are getting vaster, and the distant galaxies are receding from us faster and faster. This quiet, persistent energy will likely determine the ultimate fate of our universe. Let us travel now not just through space, but through time. We go all the way back to the beginning, 13.8 billion years ago. There was no space, no time as we know it. Everything, all the energy, all the matter that would ever exist, was concentrated into a single point of infinite density. And then, the Big Bang. It was not an explosion in space, but the expansion of space itself, everywhere, at once. In the first fraction of a second, the universe expanded faster than the speed of light, a period called inflation. It was a moment of unimaginable creation. As the universe expanded, it cooled. Energy condensed into the first particles. For the first 380,000 years, the universe was a hot, dense, opaque fog. Light was trapped, endlessly scattering off free-floating electrons. But then, the universe cooled enough for atoms to form. Electrons were captured into orbits around protons, and for the first time, light was free to travel unimpeded across the cosmos. That first light is still traveling today. It has been stretched by the expansion of the universe into faint microwaves. This is the cosmic microwave background radiation. It is the afterglow of creation, the oldest photograph of our universe, a faint, warm whisper from the dawn of time. In the far, far future, the story will continue. Trillions of years from now, after the last star has burned out and faded away, the universe will enter a dark era. The only objects left will be the remnants: white dwarfs, neutron stars, and black holes. Even these will not last forever. Over unimaginable timescales, black holes themselves are thought to slowly evaporate through a process called Hawking radiation, returning their energy back to the universe in a final faint burst of light. The universe will continue to expand, growing colder, darker, and emptier, until it reaches a state of maximum entropy, a final, peaceful equilibrium. A cold, silent, and eternal night. This is one possible ending, but it is so far in the future that it is beyond all human comprehension. The universe is still in its vibrant, youthful morning. Our journey is now coming to a close. We have traveled from our home to the moon, to the stars, to other galaxies, and through the depths of time itself. We bring our awareness back to the gentle rhythm of your own breath, back to the feeling of comfort and rest. The universe is not something separate from you. It is within you. The iron in your blood, the calcium in your bones, the oxygen you breathe. Every atom was created in the heart of a star. You are a living, breathing, thinking piece of the cosmos. Through your eyes, the universe is able to see its own magnificent beauty. Through your mind, it is able to wonder about its own existence. You are not small. You are a part of this immense and incredible story. And now, it is time to rest. Let these wonders settle. Let them become a part of your dreams. Let the vast, quiet peace of the cosmos be your peace. Sleep well, traveler. All right, the next story we settle into is about deep time, the faint hum of cosmic interconnection, and a mystery that only began to unfold when everything in the outer solar system aligned in a way no physicist thought possible. This is the tale of Project Lachesis, and the unsettling whispers carried on the solar wind during the solstice of Eridanus. Part 1. The arrival of the rogue shepherd. In the cold, perpetual darkness that lies beyond the Kuiper Belt, past the final, lonely sentinels of ice and rock, a celestial body was moving. It wasn't a comet, pulled by the sun's fierce gravity. It wasn't a Kuiper Belt object, tethered to the ecliptic plane. It was an object catalogued as Xylos, a rogue exoplanet, roughly the mass of Mars, traveling on an impossibly shallow hyperbolic trajectory that was bringing it into our Oort cloud, yet not towards our Sunday. Imagine the Oort cloud, that vast spherical shell of icy debris as the very edge of our sun's dominion, a shimmering, silent boundary between the known and the interstellar void. For millennia, it has remained undisturbed, a frozen record of the solar system's birth. But Xylos, this quiet, dense traveler, was slicing through it like a ghost ship through heavy mist. The scientists at Project Lachesis, operating out of a subterranean complex in the Atacama, initially dismissed it as a statistical anomaly. Xylos was too dense to be a captured object, too distant to be a planet, and its velocity was subtly wrong. It was moving too slowly, yet with an inexplicable rotational frequency. Dr. Elias Thorne, head of the project, often described it to his interns as a silent shepherd, because its passage wasn't causing gravitational chaos. Instead, the distant cometary bodies ahead of it seemed to be settling, their orbits becoming unnaturally orderly, as if drawn into a state of subtle rotational peace. This state of uncanny quietude was the first clue. Gravity we understand, chaos we anticipate. But this induced cosmic order suggested a force that was less about brute mass and more about resonant fields. Xylos was not just moving through space, it was interacting with the fabric of space-time in a way our current models could only vaguely predict, leaving a wake of unnatural stillness in its path. We often forget that space is not empty. It's a plasma-infused medium, a vast electrical conductor, and Xylos seemed to be tuning it. Part 2. The Silence of the Sentinel. Roughly 2 months after Xylos's initial detection, and just as it entered the inner Oort cloud boundary, our attention was wrenched toward the very frontier of interstellar space, Voyager 1. The oldest, loneliest messenger humanity has ever launched, now traveling through the turbulent, magnetically active realm of the interstellar medium. For decades, Voyager's plasma wave subsystem had been sending back a steady, albeit faint, recording of the density and magnetic pressure outside the sun's influence. It was the sound of space, a low, oscillating hum. Then, at 3:17 UTC on the morning of the solstice, the hum stopped. Not a sudden catastrophic failure, which would have indicated a micrometeorite strike or power loss. Instead, the data stream showed a perfect, complex harmonic spike, a signature so mathematically pure, it initially triggered a data corruption warning. The spike lasted exactly 4.83 seconds, and then the plasma wave detector went dead. Silence. A digital void that stretched for 3 hours before the system miraculously rebooted, only to report normal but inexplicably weakened background noise. Dr. Thorne, a man who rarely used adjectives stronger than noteworthy, called the initial 4.83-second burst a signature of deliberate compression. The energy was not random. It was structured, like a perfect chord struck on a gigantic interstellar string. It suggested that a colossal wave of structured energy, perhaps an extremely low-frequency electromagnetic pulse, had washed over the probe. A wave that carried a pattern, not noise. What was the common thread? Xylos was still hundreds of billions of kilometers away from Voyager, yet the moment of the signal's emission was calculated to have perfectly intersected with the time Xylos crossed a major heliopause boundary relative to the plane of the ecliptic. It was a conjunction of events separated by unimaginable distances, yet connected by a single, terrifying timestamp. Part 3. The geometric veil of Saturn, the third, and perhaps most beautiful piece of the puzzle, appeared orbiting the ringed jewel of the solar system, Saturn. Saturn's rings are a masterpiece of chaos and gravity, billions of particles of ice and dust, constantly colliding, shaped by the push and pull of its many moons. The ring system is dynamic, complex and utterly predictable under the laws of physics. However, a global amateur astronomy collective, monitoring Saturn's rings for the annual Mimas resonance shift, captured something unprecedented. A new, perfectly defined, faint K-ring had formed in the outer F-ring zone. This ring was not a cloud of particles, it was a structure. It possessed a lattice-like geometry that was visible only under specific infrared spectrums, forming a series of non-Keplerian shapes, squares, tetrahedrons, and perfect hexagons that rotated not by gravitational rules, but by an internal, synchronous frequency. The material forming the K-ring was not typical water ice. Spectroscopic analysis suggested charged silicates infused with rare earth plasma, and its formation was instantaneous, not gradual. It appeared overnight, on the very day the Voyager signal went silent. This geometric construction, defying the mathematics of orbit mechanics, suggested an active manipulation of the magnetic field lines. Saturn is a giant magnetic dynamo. Its rings are essentially vast plasma screens. The K-ring was acting like a colossal circuit board, holding impossible shapes in place through an unseen electromagnetic framework. Thorne theorized it was a triangulation point. The rogue planet Xylos, the charged particle field of the Oort cloud, and the magnetic field of Saturn were not three separate entities. They were nodes in an ancient, forgotten network. Part 4. The inevitable alignment. The ultimate realization lay in the calendar. The solstice of Eridanus. This wasn't a modern alignment. It was an ancient, calculated celestial moment when the center of the Milky Way galaxy, the plane of the solar system, and the most distant star in the Eridanus constellation that the ancients could track, all fell into a near-perfect 33.3-degree angle. This particular angle, according to obscure astronomical texts recovered from a forgotten observatory in the Himalayas, was called the angle of zero entropy, the point where the flow of cosmic energy achieves maximum coherence. Every event that had transpired, the calming field around Xylos, the perfect harmonic spike from Voyager, and the geometric formation of Saturn's K-ring, had been timed not to the modern Julian date, but to this ancient, almost mythic solstice. The hypothesis: what if the solar system, with its planets, its magnetic fields, and its plasma sheaths, was not merely a mechanical clockwork, but a vast, organic, resonating instrument? And what if Xylos wasn't a rogue planet, but a key, a massive, natural tuning fork, designed to enter a specific region of the Oort cloud at a specific time, to induce a coherent magnetic field resonance that would travel through the interstellar medium, strike the Voyager probe at the perfect instant, and finally, activate the solar system's primary magnetic node, Saturn, to display a geometric signal. The signal wasn't a radio transmission. It wasn't a light pulse. It was a structure. A temporary, perfect architectural arrangement in the plasma of the rings. A message written in the language of pure physics and geometry, lasting only a few weeks until the solstice alignment broke. The whispers carried by the solar wind were not random. They were the gentle hum of this cosmic mechanism, coming to life after eons of silence. Epilogue. The deep hum of connection. As we watch the solstice pass and the K-ring slowly dissolves back into the random chaos of Saturn's dust, we are left not with answers, but with a profound sense of awe. The events suggest a vast, interconnected ecology of energy, where the movements of a single rogue body can ripple across light years and awaken ancient, dormant physics. It forces us to reconsider what coincidence truly means in a universe defined by laws we have barely begun to scratch the surface of. Perhaps the greatest lesson from Xylos, Voyager, and Saturn's geometric veil is this: we are not observers in a cold, silent universe. We are living within a massive, intricately wired machine that occasionally, gently, and with infinite patience, sends us a message written in the language of stars and magnetic fields. Rest now. Let your mind drift with the slow, resonant currents of the cosmos. The universe is awake, and its humming is the softest lullaby. Good night. Okay, let's go to the next story. Close your eyes if you like, or keep them softly open. Let them fall into the gentle half-light, where room and sky breathe together. Breathe once, slowly, as if inhaling a secret the universe has been whispering for billions of years. Breathe out. Release the day, like a small stone dropped into a wide, patient pond. Tonight we will walk, softly and carefully, along the edges of wonder. Imagine first a single point of light, far beyond the reach of your fingertips. It hangs in the vast blue-black, a patient ember in the dark. That light is an ancient letter, written in photons and carried for eons across loneliness and time. Each photon is a tiny messenger telling a story of clouds collapsing, of pressure building, of eventual fire. It tells us how a star was born. We begin in a nursery, not of cradles and lullabies, but of dust and quiet gravity. In these vast stellar nurseries, clouds of hydrogen breathe and sigh. They swirl and settle, a slow, graceful choreography. Regions within them grow heavier, tiny seeds of density that call to each other. Gravity, subtle and relentless, draws them closer until warmth blooms in the heart of a contracting cloud. At first, there is only the hush of atoms colliding, but then the hush becomes a murmur, and the murmur a steady hum, the birth heartbeat of a star. Picture that newborn star like a candle cupped against a blizzard, fragile yet defiant. It begins its long work of turning matter into light, forging heavier elements in its crucible. Over millions or billions of years, it is both creator and instrument. Carbon, nitrogen, oxygen. These are not gifts dropped from nowhere. They are the labor of stars, the slow alchemy that stitched the periodic table into patterns that would one day be read by biology. Drift now to the patient geometry of planets. The protoplanetary disk that surrounds a young star is a slow-turning carousel. Dust grains stick like shy dancers, finding partners. Pebbles accumulate to rocks, rocks to boulders, and boulders, by a kind of stubborn fortune, become worlds. Each planet falls into its lane, some near and scorched, others distant, wrapped in the deep sleep of frozen gases. Some catch thick atmospheres and wear them like robes. Others are bare, their scarred surfaces reading like old maps. Listen. The language of geology speaks in storms and tides, in continents wandering on oceans of rock, in the patient corrosion of winds. On some worlds, water pools and waits rivers tracing the skin of the planet, oceans breathing with the slow rhythm of tides. Where chemistry and liquid meet, curiosity becomes possible. Where energy is steady and ingredients meet for long enough, chemistry can begin to take the first timid steps toward biology. Life, when it appears, is not an announcement so much as a very quiet persistence. It is the universe learning to know itself through rearranged atoms and the improbable poetry of replication. Let your mind stroll now beyond the pale neighborhood of a single star to the wider assemblies, binary stars that spin around each other in an intimate conversation. Systems where planets chase one another in complex arcs, moons that steal the stage and then return it. Imagine a night sky from the surface of a world that circles two suns. Dawn here and dusk there, shadows overlaying and unraveling, as if the universe were practicing a gentle illusion. Or imagine a planet where the seasons stretch for centuries, and an entire civilization learns patience from a slow, wandering orbit. We can come closer, closer than even the crescent of a moon, and meet comets. Comets are wayfarers, icy, ancient, carrying the scent of the outer reaches. When they approach a star, heat teases their frozen past into jets of dust and gas. creating a tale that points away, like a memory streaming behind a moving soul. Some comets have visited the young Earth, delivering water and organic molecules, small serendipitous couriers, possibly responsible for nudging chemistry toward life. They are reminders of how the universe keeps its treasures in remote vaults until the right moment. Now, allow the scene to widen. The galaxy is not a static painting, but a slow-turning ocean of stars. Our Milky Way is a disk of countless lights, an elegant swirl observed edge-on as a delicate line of soft brightness, or seen from within as a band of spilled sugar across the night. The galaxy's spirals are arms roots of ongoing formation, places where gas is funneled, compressed, and nudged into new generations of stars. At the center sits a quiet storm, a supermassive black hole, not a hungry villain in a storybook sense, but a sculptor whose gravity molds the dance of millions of suns. Black holes are not only endings, they are thresholds. Their gravity warps both space and time, bowing light as if the fabric of reality were a soft sheet. When a black hole feeds, it can make light brighter than entire galaxies, an irony that reminds us how extremes are sometimes necessary to create beauty. Around many black holes, matter swirls in a furious incandescent maelstrom, jets of particles leaping outward like fountains that pierce the dark. The mathematics that describe such objects are both austere and wondrous, a vocabulary where infinity and smallness meet. Think for a moment about the scales we talk about. Atoms to planets, planets to galaxies, galaxies to clusters, and then to the cosmic web. Between galaxy clusters, filaments of gas and dark matter trace a pattern like frost on a window. Dark matter, an invisible presence, holds the web taut, a scaffolding without which galaxies would not gather. Though we cannot see it with our eyes, we sense its gravity by watching things move as if pulled by invisible hands. There is humility in that. Much of what shapes the universe is one step removed from our senses, and yet is no less real. Time itself carries a story. The cosmic microwave background is a faint afterglow of the universe's earliest visible chapter, a whisper from when the universe was just a few 100,000 years old. It is cool now, a mere 2.7 degrees above absolute zero. But it is a map, a photograph of the infant cosmos, with tiny fluctuations that seeded everything that followed. To hold that image in your mind is to understand that even the largest things started as the smallest differences, tiniest ripples that eventually grew into vast structures. Picture the cosmic timeline like an old patient book. The first pages are quick and feverish. Inflation, a sudden stretching that smoothed space like kneading dough. Then atoms formed, light untangled from matter, and a dark age fell long and silent until the first stars lit tiny lamps that pushed back the gloom. Galaxies assembled, merged, and spun off new generations of stars. Planets formed from the debris left in the aftermath of these cosmic negotiations. In this unfolding, humanity appears very late, an afterthought in the second-to-last paragraph. And yet, in the human mind, a universe of meaning ignites. Let us visit one small chapter in which curiosity itself evolves. Consciousness. Somewhere in the long history of Earth, early cells invented a trick replication with variation. And then, over eons, nervous systems learned to sense. Brains are storytellers. They knit signals into patterns and name them. Consciousness is an emergent candle, lit by complexity, sustained by exchange, and flickering with memory. It is in this candlelight that we ask why and how, and in asking, we create narratives that fold the cosmos back onto itself. Imagine now an observer standing at the edge of a cliff beneath a trembling aurora, or a night watchman on a ship gazing at the stars smeared with meteor trails. The same processes that cook the insides of stars also create the copper in your phone camera, the oxygen in your lungs, the metal in a bridge, the calcium in a tooth. These are all descendants of ancient stellar furnaces. There is a soft, almost ineffable intimacy in that. The universe gave us, over long patience, the very elements that make selfhood possible. We can also sense the fragility of home. A planet's atmosphere is a delicate blanket. It can warm gently under a benevolent star and sustain richness, or it can be stripped away by flares and winds, leaving raw stone. Small differences in chemistry, rotation, or magnetic shields can mean the difference between a world teeming with potential and one that remains mute and barren. The history of planets is a study in chance and contingency. Local weather, global catastrophes, rare impacts, the ephemeral vicissitudes that shape long-term trajectories. Turn your attention now to communication across distances. Light is a faithful courier, but it travels at an upper limit. Signals sent across interstellar space take years, centuries, or millennia to arrive. Even at light speed, messages are delayed by the tyranny of scale. If someone on a planet 500 light-years away shouts into the dark, their voice is a letter that will arrive here only 5 centuries from now. That slowness teaches humility and patience to any mind that imagines sending greetings. Consider how we listen. Our instruments extend senses. Radio telescopes tune to the faint hum of hydrogen between galaxies. Spectrometers unweave starlight into colors and reveal composition like detectives reading fingerprints. When we find a spectrum with telltale signatures, water, methane, oxygen, we do a kind of forensic archaeology across time and space. We cannot visit many of these places. Instead, we learn to translate the light they send, to read whispers of chemistry and motion, and to infer landscapes from small, indirect clues. There is also the poetry of scale in motion. Galaxies collide not as catastrophic bangs, but as slow, majestic ballets that stretch across millions of years. When two galaxies meet, their stars mostly pass like ghosts, but their gas clouds crash and ignite bursts of star formation, new lights born from the turbulence. In the far future, our Milky Way will kiss Andromeda in such a dance, a slow merging that will change the map of the night, but will not necessarily be an apocalypse for individual systems. Time grants the universe a kind of patience we cannot fully fathom. Let us touch, briefly, on endings and beginnings folded into one. Stars of certain masses end their lives with a final flourish. They swell into red giants and drop outer shells that smell of future gardens, planetary nebulae, whose glowing rings are nothing less than stellar farewell notes. Some massive stars go out as supernovae. They explode with a brightness that can outshine entire galaxies for a while, scattering heavy elements into the void. These explosions are fertile. They pepper the interstellar medium with the seeds for future planets and life. The iron in your blood was once inside a star that died in fire. And then there are rarer endpoints. Neutron stars compacted into the mass of the sun, but squeezed into a city-sized sphere. Spinning so fast, they sweep beams of radiation across space like distant lighthouses. When two neutron stars merge, they ring the cosmos in gravitational waves, ripples in space-time itself. These ripples are like the faint tremors of a gigantic bell, small on our scales but monumental on a cosmic ledger. We have learned to hear them, to listen to space-time, and in doing so, we have opened a new sense. Now imagine, for a slow moment, a distant sea, where bioluminescent organisms light up like stars in miniature. Each little flash a private signal, an invitation, a memory. On some exoplanets, life, if present, might glow under active skies, or it could be hidden within subsurface oceans under a frozen crust. Moons like Europa or Enceladus, in our own system, hide oceans beneath icy shells. There is something deeply consoling about water kept warm and dark for aeons about the patient possibility contained in enclosed seas. If life exists elsewhere, perhaps it is quiet, tucked into corners where chemistry can be steady and undisturbed. Let your thoughts wander to civilizations, which may exist as brief candle flares along a long timeline. The technological curve of a species could rise quickly and fade due to self-made or natural disasters. It could also plateau into a sustainable, quiet stewardship. We do not know. We only know our own species' late curiosity and the sudden brightness of our signals leaking into space like dandelion seeds in a wind. Radio and light-based signals expand outward, thin and faint, like footprints in powder snow, detectable at a distance if someone is both listening and clever enough. There is comfort here too. Loneliness on cosmic scales does not mean emptiness. The cosmos is full of patient processes. Life and intelligence, if rare, may be spread like scattered campfires across an enormous plain. And perhaps the act of knowing, of looking, measuring, imagining, binds us into a community with the rest of the cosmos. In studying stars and particles, in parsing spectra, and building telescopes, we cast ourselves as students in a grand school. As you listen, either with your ears or with your mind, feel the rhythm of the universe as a lullaby of durations. A human lifetime is a handful of breaths compared to geological ages, and geological ages are a blink beside cosmic epochs. Yet within a single heartbeat, we can hold awe, grief, curiosity, and love. These human scales are not failures of perspective. They are the universe experiencing itself in a compact, fervent form. Now, imagine returning home, descending slowly from the bright cathedral of the galaxy, through the still, cold arms of interstellar space, past the commuter belts of comets, past the warm glow of a friendly star. You approach a tiny blue planet, the home you know. From orbit, continents are soft petals and storms curl like calligraphy. Cities are small nodes of light, patterns of habit and story woven together. On one such night, someone looks up with an ancient sort of yearning, recognizing in the dots above both estrangement and kinship. To end, consider this quiet, generous truth. You are made from the same elements as the stars, and those elements have traveled cosmic distances to arrive, patient as rain, into your bones. Your thoughts are shaped by molecules forged in fire. Your curiosity is a continuation, an echo of the processes that stoke stars and fold galaxies. In that sense, the cosmos is not merely something outside, it is an inheritance and a companion. So let tonight be ordinary and extraordinary at once. Let the soft knowledge of distant light settle in like warm dust. If sleep comes, let it be gentle, like the slow drift of an orbit. If your mind wanders, let it wander along the spiral arms, where new stars are still being hatched. Tomorrow, when you open your eyes, the world will feel familiar and newly strange, and you will carry with you the hush of long distances, the patient grammar of the universe, and finally, a closing image. A small child on the threshold of a house, holding a lantern. The child is not yet sure what stories will come, but they are learning to read the sky. The lantern casts a gentle circle of light, and, within it, the child's face is full of person-sized astonishment. Outside that circle unfolds a darkness so wide and generous that it invites stories rather than denies them. Walk now into that small, safe pool of light. Breathe, and let the vastness sing you slowly into rest. Good night. And now, as the night settles deeper, and the world loosens its grip, let us lean into a quieter orbit. Take a slow breath in, let it drift out, and imagine a small, golden circle turning in the dark. No countdowns, no roar of engines, just a record, patient as a heartbeat, sealed to the side of a departing machine. This is our next journey. It begins with a needle and a groove, with a message pressed into metal and launched into forever. Tonight's story is called The Voyager's Golden Record. Picture a room late at night, lights low, a turntable waiting. You lift a record from its sleeve, hold the warm weight in your palms, then set it down. A stylus lowers, a hiss like distant rain. And then, voices, music, thunder and birds. The sound of a mother greeting a child. You are not alone anymore. You are connected by a ribbon of vibrations to the place where the recording happened, to the air that trembled when those words were first spoken. That's what a record can do. Now take that feeling, that thin golden bridge between two moments, and pull it longer, longer, until it spans not a room or an hour, but a solar system and 1,000,000 years. That is the ambition tucked inside two small spacecraft named Voyager. In the late 1970 seconds, two identical probes were guided onto paths that would carry them past the outer giants, Jupiter and Saturn for one, and for its twin, still farther, to Uranus and Neptune. The timing was rare. The big planets happened to line up in a way that allowed each encounter to sling the spacecraft to the next. A gravitational hopscotch called a grand tour. The Voyagers carried cameras and detectors to read magnetic fields and count charged particles, to sniff the chemistry of atmospheres and measure dust. But they also carried something not required by any engineering specification. A phonograph record, plated in gold, tucked into an aluminum case on the spacecraft's body, with instructions etched into the cover. The idea was simple and audacious at once. If anything ever found this craft adrift in the deep dark, the record might be played. It might speak for us. Gold is patient in space. It does not rust or cloud easily. The record itself is copper, gold-plated for endurance. On its jacket, diagrams explain how to use it, how fast to spin it, how to position the stylus, how to decode the pictures stored as a rising and falling signal. A map points back to us, using the pulsing hearts of dead stars' pulsars as waymarkers, their ticking frequencies engraved in a universal unit set by the spin flip of hydrogen. There is even a tiny sample of radioactive material on the cover, so that a careful future reader could measure its decay and know how long the record had been traveling. It is a time capsule that provides its own clock, its own compass, and its own instruction manual. What does it say? Almost everything it can, in the small space, aloud. There are greetings spoken in dozens of languages. Hellos, welcomes, well wishes, small messages of peace sent from a planet that is not always peaceful. There are sounds of Earth, wind, surf, thunder, crickets, footsteps, a heartbeat, a kiss, the machinery of our living tractors in a field, a train crossing a bridge, a rocket trembling a launch pad. There are songs, music from many traditions and centuries, string quartets and choir, blues that aches with cold nights, drums that call to dancing, a bright guitar that once made teenagers in diners move their feet. There is a lone voice saying, "Hello from the children of planet Earth." A sentence so simple and clean that it feels like a lighthouse blink from shore to far sea. There are pictures too, encoded as sound and meant to be retrieved by drawing their lines back out. Images of our bodies and our homes, of mountains and rivers and cities and farms, of a mother and child, of a page of mathematical definitions, of a human hand with a circle scribbled beside it to help with scale. There are scientific diagrams, biochemistry, the structure of DNA, a portrait of our star and its family of worlds. And somewhere in that gallery, there is a photograph of the blue sphere that holds all of this, suspended in black. It is both more than enough and not nearly enough, but it is a start. The two Voyagers rode their rare paths with breathtaking success. They flew by Jupiter and watched its storms roll, and its moons show themselves as worlds in their own right. Volcanic Io, with plumes blooming above its yellow plains. Icy Europa, scored with lines like cracked glass. Ganymede, big enough to have its own magnetic field. Callisto, old and cratered like a memory of the early solar system. They dove by Saturn and saw the rings as a structure, not a band, braided, scalloped, shepherded by moons that carve gaps, the way boats cut channels through ice. One Voyager pressed on to the pale worlds farther still, showing Uranus tilted like a rolling barrel, and Neptune dark-eyed and windy. And Triton, its moon, framed by geysers that wrote weather on an air as thin as a thought. They saw things nobody had seen. Then, after the cameras took a last look home and turned off to save power, the spacecraft kept going. At some uncertain boundary, the sun's breath gives out. The bubble that our star blows into space, our heliosphere ends, and the interstellar medium takes over. The Voyagers pushed through that boundary and reported the change. The direction of magnetic fields shifted, the density of particles altered, the texture of the radio hiss around them changed. Out is not a cliff, but a slow crossing, a gradient from familiar to wider. Out there, their energy comes from a small supply of heat, set free by the decay of a metal inside them, changing to electricity through devices that conduct heat like a one-way street. Every year, power fades. Every year, instruments shut down to keep a few core senses alive. There are long silences now. Sometimes a message is garbled, sometimes a whisper returns. But the craft still move, writing their thin lines through a diagram which no one can hang on a wall except as a metaphor. A map of leaving, sometime in the far future, even after the last instrument is silent, the records will remain. They will drift with their carriers through a medium that is not quite empty. If no one ever finds them, then the message will have traveled for nothing but our own benefit, because crafting it made us ask, with unusual clarity, who are we, and what do we want to say? That was always part of the point. But there is another possibility that is gentler and strange, that one day, in a time so far ahead that we might as well call it a fairy tale, someone will notice a weak, moving point against their own constellations. They will track and predict and meet. They will bring the patient thing aboard a metal flower long since cold, painted in dust, and they will open the case and consider the diagrams. They will find a stylus included and an image on the cover that shows what to do. They will spin the disc at the speed indicated by a small etched number. They will press the needle into the groove. The first sound will not be words. It will be a thunder of surf and wind and water, camera-shy and ancient, an ocean speaking one syllable in every language. Then perhaps a greeting will arrive in a tongue never heard beyond Earth before. A hidden part of their mind might react without any shared dictionary, because the greeting sounds like a greeting no matter what you know. The cadence of someone addressing someone else with attention. A child's voice may follow. Music will arrive that is built on ratios common to our bones, even if not to our culture. What would they make of a 12-bar blues night? Of a string quartet bidding evening to a rose? Of a voice from the desert singing to dawn? Let the question be a soft horizon line. It's enough at bedtime to look toward it, not to answer it. After sound, pictures, they will feed the signal into a scanner and watch as lines bloom into images. The first is simple, a circle that tells you where the edges are, a calibration to help your eye know what it is seeing, then a page of units, then a tree, a landscape, a city, a mother holding a baby in a way that makes a lump rise in your throat, even if you have never held one, a spectrum of the sun like a barcode, the DNA double helix climbing a ladder of numbers, the chemical alphabet of life, a handshake, a grocery store, a photo of a schoolroom where someone drew a triangle and called it truth. It's not everything, but it's our handwriting in the margin of the universe, legible to anyone who is patient with puzzles. Now come back for a moment to the tabletop with the turntable and the soft light. Imagine that it's you who is the one finding the record, because in a way, every time you remember that it exists, every time you play in your mind what it contains, You are the receiver at the edge of the dark. What does the record say about us? It tells of our curiosity, the way we cannot help pointing lenses at things and asking them to give up their secrets. It tells of our variety, many languages, many rhythms, many rituals to navigate joy and grief. It tells of our technical discipline. We can measure, we can etch a map with pulsars and trust that anyone who can travel across the void can read it. It tells of a small humility too. Tucked among the confident diagrams are the sounds of frogs and rain and laughter, as if to admit that what really matters about us is not only what we know, but how we live. The record is a mirror. It reminds us that to be human is to hold the world in your ear for a while and listen. The cover art is itself a poem. On the left, a setting showing how to play the disc, how to drop the stylus, which side to choose, how to set the speed. Above, a clock tick drawn from the atom most common in the universe, so that anyone with a physics and a radio can reconstruct our unit of time. On the right, a map of pulsing lighthouses, their tick rates etched in the same time unit, so that triangulation from a few will point to the place where the record was launched. At the bottom, an outline of the disc and its stylus, with the stylus drawn in a different position to represent time passing during playback. It is all very practical and at the same time very beautiful, like the diagram of a musical instrument a careful maker might draw. Who chose the contents? People with different expertises sat together and argued kindly about what could not be left out. A physicist who had sent messages before. A writer with a fierce tenderness for life. Musicians and linguists and scientists who kept asking, "Do we have room for this? What about this?" They were limited not just by space measured in minutes and megabytes, but by the reality that every inclusion is an exclusion. For every song there is 1,000 not included. For every picture, 1,000 lives just outside the frame. They did their best. If, one day, you are awake at 3 a.m. and feeling like a gnat on a window pane looking out at a rainstorm, it can be steadying to remember that a small committee of humans worked very hard to give the universe a fair sample of what it feels like to be us. Perhaps you've heard of one last photograph. A Voyager took a portrait of home from far away, where our planet is a pale dot caught in a shaft of scattered sunlight. Even if you haven't, you can feel what such a view would do to a person. The way it presses the breath out of you without panic, leaving you lighter. The record carries that same perspective, but in sound. The great far away made intimate. You put your ear to a circle of metal, and a breeze moves through the leaves of a tree you will never sit beneath. You hear the fluting of a bird whose name you do not know, and you do not need to know. A single voice says hello, and you are a little less alone. There is a quiet, practical courage in sending a record into the dark. It admits that we are not the center of everything. It admits we may not be listened to. It admits we want to be known anyway. It is the act of a species that sometimes sets a table for a guest who might never arrive, simply because that is who we hope to be. A record is a table. A groove is a plate. A stylus is a knife and a fork negotiating warmth from something that was cold when you set it down. Let's imagine an unwrapping, then, on a world not our own. A being like us in curiosity and different from us in almost everything else kneels beside the artifact. They puzzle out the diagrams and, with a few false starts, they coax the first audio out of the groove. They smile, or whatever their version of smiling is, because the messiness of analog comes through. A pop here, a hiss there, the voice of a singer riding a ribbon of noise like a surfer on a break. They adjust. The music steadies. Then, maybe because this is what music does, they look up from the machine and out into the open. And something about the line of their horizon looks kinder for a moment. They have just learned that somewhere else, minds arrange sound to make time feel less lonely. They do not know our words for it, but they know what it is. If the record is found not by strangers but by none at all, it will continue on, slumbering in a black that is never truly empty. It will outlast mountains on earth, and languages, and perhaps our species. It will travel through regions of space, where the density of atoms is a handful per cubic centimeter, then through fluffier deserts between spiral arms, then perhaps brush against a tendril of gas licking out from a passing star. It will warm slightly as it passes invisible fields, then cool slightly, keeping its counsel. The message does not care. The message is content to be available, to exist as an offering beyond the reach of the offered. Sometimes, when people speak of this record, they argue. Should we advertise ourselves? Should we have said more? Should we have asked less? These are reasonable worries, because the world is not a perfect host for its own inhabitants. Why would the universe be kinder? But there is a different symmetry to consider. When you tuck a note in a bottle and set it on the tide, you are not merely hoping for an answer, you are naming yourself to yourself. You are saying, I am the kind of being, How writes, who hopes, who greets. The record says this about us. We are makers of grooves and listeners to echoes, builders of diagrams and tellers of jokes. We are a family, as primitive and as refined as that word implies. So let the night stretch thin now. Let the turntable in your mind spin. Listen as the track list steps from thunder to a child's voice, from heartbeat to horn, from a crackling campfire to a violin, tracing the outline of a horizon you can't see but recognize. The room you're in, bed, pillow, window, takes on the comforting attention of a spacecraft's small body. Instruments stowed, systems powering down, the golden disk secured. Somewhere, many times farther than you have ever traveled, two such bodies are still coasting, long past the last planet, carrying the warm proof that we tried to say hello. And when your eyes start to close, picture that etched cover, the hydrogen clock, the map of pulsing stars, the diagram of the player, the invitation written in geometry. Imagine a hand from far away following those lines centuries from now, with the patient curiosity of the best readers. Imagine the first ounce of sound spilling into a room that has never known Earth. Imagine the pause afterward, the most human of all silences, the one that means, I heard you. Then let your breath make that silence in your own room. Now, softly, we have reached the outer edge of our little tale. The turntable slows, the stylus lifts, the record moves back into its sleeve. The spacecraft keeps going, small and faithful, turning its golden ornament to the stars like a locket. You are here, on a blue world where wind has its own music and morning will return. You can sleep, knowing that somewhere in the dark, our best hello is still on its way. Good night, traveler. Good night, record. And to you, listening in the quiet, thank you for keeping watch with me until the end of this track. Okay, this journey of galaxy end here.